Welcome to today's Intelligent Utility Reality webcast entitled, Getting in Sync, Here Comes 3D, the Next Generation of Interoperability. A few housekeeping notes we would like to mention. For best results in viewing this presentation, we recommend using a wired high-speed internet connection, as wireless connections can be unpredictable. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. We're happy to thank Elster for making today's event possible. Today's panel is Pat Corrigan, Vice President, Public Utilities for Elster, Richard Gray, Manager of Enterprise Architecture, Kansas City Power and Light, and Doug Lampert, Multi-Speak Program Manager in our ECA. Now I'd like to turn the floor over to Mike Smith, Vice President, Utility Analytics Institute, the moderator of today's event. Mike, welcome to the event. You have the floor.
Thanks, PJ, and good morning or good afternoon, everybody, as the case may be. It's a pleasure to be here with everybody today, and we know how busy folks are, and we really appreciate you taking some time to spend some time with us today to talk about interoperability and really looking where this is going, more so than I would argue where it is today. We've got three great speakers, and we're looking forward to sharing some of their thoughts with you, so let's jump right into this. Next slide, please. In preparing for the session today, we did a little research and looked at some different things from the Smart Grid Interoperability panel to some information from the Energy Information Agency. Just pulled a few things together, including some of our own research here at the Institute and Energy Central. I'm not one to read slides typically, but this definition is one that we came across in putting this together, and I will call your attention to the last sentence of this definition, where interoperability and standards activities are not limited to technical information standards. They must be advanced in conjunction with business process, markets, and the regulatory environment. That, of course, is really important. We see the interoperability movement, if you will, as one that is getting traction in the industry, and there's a lot of interesting developments there. But what we'll be talking about today is just that, and that is moving beyond just the technical standards portion, where we get into the actual applications and how this can really impact and drive and change positive business change. Next slide, please. This is something we put together actually when we were just kind of looking at how the landscape has changed, particularly over the last, I'll say, 4 to 5 years with this intelligent infrastructure, aka smart grids and smart meters that have been built out over this time frame. Prior to that, there was some fairly what I would call set technology that was out there, had incremental change, always improving. But I think we can all agree that these investments that our industry has made in this intelligent infrastructure really is a game changer, and we'll look at that here in just a minute. Next slide, please. Kind of today, what we see is a much more robust infrastructure that certainly has a lot of promise, and we're starting to see some delivery on that promise. A couple of the things that really leap out at us when we look at this is the deployed intelligence that's really penetrated across the grid. Back in what I'll call the old days, most utilities looked at having automation on the operations side, for instance, down to the substation level. In fact, we had a lot of definitions around what the boundaries were for automation and how those systems or technologies were integrated, if at all. With this intelligent infrastructure today, those definitions and those traditional boundaries have completely gone away, which creates a lot of opportunities, but also some challenges. And we'll be hearing about a lot of that today. Next slide, please. And just in wrapping up my opening remarks, we can see that here in North America, really just in the U.S. alone, there's been 40 million smart meters installed. And most of those have happened, of course, since the 2008-2009 time frame. There's billions of dollars in smart grid infrastructure installed. We look at these markets a lot, and we see projects on the low end being probably in the $50 to $100 million range, and on the high end being, in some cases, several billion dollars. In the case of one large utility out here on the West Coast line base, it was $2.1 billion. Really an unprecedented level of investment in this intelligent infrastructure that really does drive a lot of opportunities. One of the offshoots of this infrastructure investment is not only is there a growth in the ability to roll out new applications and do new things with the data that's a result of this infrastructure, but we would argue that expectations have grown as well. Expectations within the utility organization and within the industry, and also more importantly with our customers. You know, the example we draw quite frequently, and I'm sure a lot of you have seen this example as well, is you look at customer expectations around telecommunications with cell phones and basically holding the world in the palm of your hand with a smartphone. That really ratchets up the expectations for consumers on really everything that they touch. So that's the environment that we're in today, and that's part of the challenge. As an industry, the one thing that I would note here before we move on to our presentations is we've built this infrastructure. We see standards really helping drive forward a lot of the new applications and developments we see today. But really it's about making these things all work together and doing so with a solid business case that really makes sense. So that's what we'll be talking about today. I just wanted to kind of set the table for our speakers. And along those lines, next slide, please. It's my pleasure to introduce our first speaker, Patrick Corrigan, who's Vice President of Public Utilities for Elster Solutions. In his role, Pat is responsible for Elster Solutions' public-owned utility and member-owned utility market and sales strategy, including channel management. Elster Solutions is Elster's electricity metering company, which is the originator of Elster's AMI technology called Energy Access. Pat has extensive background working in the utility industry to improve business process, develop market strategies, develop IT solutions, and manage products and markets. He consults regularly with executives from a variety of fields to help create synergistic solutions for public power customers. Prior to his current position, he managed system sales and customer service, including the creation of the sales operations and customer support processes currently used at Elster. Raised in Pennsylvania and an engineering alumni at Penn State University, Pat now lives with his family in Raleigh, North Carolina, which is Elster's North American headquarters. Pat has been honored with various awards from industry, ranging from sales, business development, and marketing and quality. He's also a trained ISO quality auditor and has attended many executive education courses around sales, marketing, and finance. It's my pleasure to introduce Patrick Corrigan. Pat, the floor is yours.
Thank you, Mike, and thank you to everybody in our virtual audience here today for this important discussion. Next slide, please. Interoperability is a challenge for many utilities and many industries, and not just utilities. As you can see here, based on a casual Google search, interoperability is most prevalent as a discussion topic in other industries, and it shows up most often in the medical industry, followed closely by the financial and energy industry. So it is a hot topic in the utility industry, in the energy industry in general, but in others as well. Next slide, please. In this case, this is an example of some work done by INSEAD that shows the relationship between increasing network capability and the natural tendency for there to be more questions about interoperability. So you see the dearth of references in the technical literature in the early years, and as you advance out into the internet and the web space, there's a tremendous increase in the technical literature and in other literature for interoperability. And as consumers experience advances in communications networks, they place demands on vendors to achieve interoperability. For an everyday example, you can look at consumers often want to buy their smartphone independent of the network supplier and apply it to whatever network they choose. Another parallel example is where consumers in our industry, in the utility industry, and they get a smart meter, and they say, well, if I have a smart meter, won't it talk to my smartphone then? Or why not? Why won't it talk to my smart appliance? So although they may not use it today, they do expect it to work in case they do decide to use it. It's a growing segment of our consumer base. Next slide, please. And our networks are increasing in capability in the utility industry. You look over the last few years even, the reach of these networks, the bandwidth and latency performance, even in the neighborhood area networks, have increased many times. Examples are the RF mesh deployments and the tower RF deployments that are common Increasingly, you see broadband RF being used as a bridge technology between the enterprise backhauls that use fiber. So all of these things are making a more robust appearance in our markets today. So the increased connectivity and bandwidth in the utility industry, just like other industries, is driving the need for more interoperability. Next slide, please. So how can we make progress? Standards making by itself usually isn't enough. Interoperability requires market momentum, resulting in investments in the kind of cross-functional bodies that provide for verification, testing, modeling, and design. And examples that we have today in our industry include the Gridwise Architecture Council's doing some fine work, the Smart Cities Council's a newer one doing some fine work, and of course the Zigbee Alliance. These are just some examples that come to mind. There are others. But other industries have taken the same approach, and they've made significant progress. Next slide, please. Market momentum, as it's required, oftentimes starts with a concept. So here's an example of what we mean by that in some previous concepts. We've probably all heard these things by now: Internet of Things, AMI, smartphone, smart meter, smart grid. Let's just use AMI as an example. AMI was one that we used at Elster very early on in 2003 when we came out with the first RF mesh network for commercial use. At the time, we anticipated it as being a step function improvement over AMR, and that we thought it would just be a better way to do AMR and some other things. But as the concept became popular and built its own market momentum, it quickly advanced beyond that and started to take on meanings with other concepts that you see here, smart meter and even smart grid, which today we're still trying to fully define out the details that go with the concept of the smart grid. So concepts or mental models help seed ideas, which can lead to market momentum, which is an important ingredient in sustaining change. Next slide, please. Mental models help provide a vision so that detailed work processes follow the same compass. The model needs to address all stakeholders and needs to drive market momentum in order to have its best chance of success. Next slide, please. The 3D model, or the 3D interoperability model or concept that we're proposing in this discussion, adds the application dimension to the more common 2D models that focused on devices and communications with one set of head-end software. The idea is to keep the model simple so it's easy to carry around in your head, and it can perhaps then be used as a springboard to the kinds of detail that will have to fall out of it in order to make it robust and usable. But it does have a profound but the simple model can have a profound cost and convenience associated with it as contrasted with past implementations. Next slide, please. Past implications as used in this model would be more akin to a 2D interoperability model. In a 2D interoperability model, which is the historical approach utilities have followed, there was a heavy focus on devices and communications. Applications were often an afterthought, resulting in one-off or custom integration efforts. This approach led to many customized back-office solutions that are expensive to develop and maintain and sometimes not very flexible. Next slide, please. It also leads to an interesting phenomenon, and I'm sure we've all heard the term silos. It's used a lot in the business literature and management consulting. But it also has a place in the technology world, and the two, I would argue, are very closely related. So let's take an example here, where let's assume we have a customer service department. And within that customer service department, you might have an AMR function. You might even have an AMI function that's confined to a CNI type accounts. You might have a demand-side management system for load control, and you might even have an outage management system, all operating under the umbrella of customer service. And all of these things, because of the way the technology came up through the years, have defined separate silos within the same customer service function within the utility. And as the technologies form silos, the business processes that were built around them within the utilities also form silos. And so we have natural barriers between things even within the same operating function within a business. Next slide, please. So with the 3D interoperability model, the concept is that a user can move along any of these axes without disrupting the function along the other axes. For example, a user could select from a variety of meters or load control devices along the horizontal axis. Or the user could select and improve communications along the vertical axis, perhaps adding a future cellular data technology. Another example would be selecting a different billing system or other application. The 3D interoperability model aspires to a full 3 degrees of freedom, meaning that technology can move along any axis without disrupting existing technology along the other axes. This approach promises lower system maintenance costs since it eliminates the rippling upgrade costs commonly associated with past 2D implementations. Next slide, please. These are some examples. These are some examples of interoperability tools that have been used in general in the IT world. It's hard to believe today that these were once nascent ideas or concepts because they're so widely accepted and adopted today. So success can be reached. Next slide, please. One element that's close to us here at Elster is the fact that perhaps everything I've told you thus far isn't enough even at that. Standards, alliances, other bodies work. Another aspect of it is that we have to have clever design. And the clever design is about taking what we know how to do in a way that makes the infrastructure more flexible so that it can change more flexibly as needs change. In this example, we're showing you a smart meter that is built for a 3D interoperability model. And the idea here is that we know that a large part of our footprint across North America, and other parts of the globe for that matter, are using a 900 megahertz RF mesh footprint for the neighborhood area networks. And we know there's a major investment there. So in this case, we're saying, why don't we build our hardware so that it has a software programmable radio protocol so that this set of hardware can adapt. If you want to use this RF mesh network today, but 5 years from now you would rather use B, or another year from later you might want to use C, or perhaps one day there is an IEEE standard for what the protocol should be within these RF mesh radios under the Smart Utility Network banner perhaps, then you could program that hardware base with this new protocol so that you can start to see, and I could go through other examples of that that are contained in this slide. But I think that illustrates the point, which was the main reason of this slide. It isn't so much to talk about the meter as it is to talk about the concept. Interoperability is more than standards. It is design, and perhaps the way to think about it is a collaborative, flexible design. Next slide, please. Next slide. And finally, but probably the highest priority, and I always argue whether I should put this slide first or last. It can work in either place, but it is about our stakeholders. And this is a busy slide on purpose. I don't like busy slides, but in this one, I couldn't avoid it. When we talk about our stakeholders, this largely captures them from a utility, a community, and a consumer standpoint. And 3D interoperability is needed to help address all of the stakeholders, the kinds of investments that we're asking our communities to make. We need to be paying attention to all the stakeholders. It will allow our communities to adopt new technology more easily as needs or preferences develop if we put forth a 3D interoperability model. Previous system approaches using the 2D models were localized. The benefits to stakeholders were constrained due to the constrained architecture. For example, AMR systems and even some of the AMI systems have been deployed with little regard for outage management systems or their benefits on the consumers or the utilities in the community. By interfacing the meters and the communications directly to the OMS, real-time power status of each homeowner can be conveyed using the same infrastructure. There are many other examples like this OMS example. Next slide, please. So in summary, 3D interoperability is a concept. It's a concept about helping us to remove silos in our technology and within our business process. The timing is right. We have affordable technology, we have deployed technology, we have capable networks. The market participants are ready. You can see it by ample examples that I gave earlier about already the entrepreneurial instincts in these organizations and councils that are forming to move forward. And then the hardware and the software technology is coming out where it's being more flexible, and the design is taking interoperability more into account up front rather than trying to build it in after the fact. And finally, keeping an eye on our stakeholders will help make sure that as we do these things, we do a much better job of communicating to all the people who have a stake in it. Thank you, and I'll turn it back to you now, Mike.
All right, thanks, Pat. And I think we'll be hearing from you during the Q&A portion later in today's presentation. It is now my pleasure to introduce our next speaker, who is Richard Gray, who is the Manager of Enterprise Architecture at Kansas City Power and Light. Richard is an accomplished IT professional with proven success leading enterprise architecture, database, data warehouse, data integration, systems integration efforts, and teams. Richard is passionate about using and managing data effectively, solving business problems using forward-looking technologies, tools, and techniques, and doing things right the first time. I think we'll all agree that that's a goal that we have. Richard has over 25 years of IT experience with over 10 years of enterprise architecture and planning experience, including 10 years of senior Oracle database architecture experience. He also has over 10 years of experience leading and managing teams in the insurance, telecom, consulting, and utilities industries. Richard has experience managing large database and data warehousing efforts, leading data governance efforts, and standing up business intelligence, service-oriented architecture and integration, and enterprise architecture practices. Richard, the floor is yours.
Thank you, Mike. Thanks for that kind introduction. Thanks to Elster and Energy Central and you for this opportunity to talk about interoperability. When you came to me and asked me to participate, I was thinking, wow, you must be having trouble finding experts, because I really don't consider myself much of an expert when it comes to this. But I am excited to talk about interoperability or integration. And as a former professional database architect, as Mike mentioned, it's all about the data and how we access it. And interoperability and integration is just the next step in our journey in using data effectively. Next slide, please. Brief agenda. Next slide, please. The obligatory, KCPL and overview. A couple of comments. We are a mid-sized, regulated investor-owned utility. We do have a fairly large geographic footprint. That in itself brings some challenges, and Pat talked about some of the radio mesh challenges that brings. We face some of those in our territories. We operate in 2 states. That means we get the pleasure of dealing with 2 public utility commissions. At times that creates its own set of difficulties as well. Next slide, please. Our goal is a promise of reliability. We want to be reliable for our customers, we want to be reliable for our shareholders, and we want to be reliable for our employees. As part of IT, and it's strange that enterprise architecture is inside IT. That really ought to be in the strategy office, but I've never been any place that's been the case. It's our goal to provide reliable delivery capabilities and services back to the business so that we can operate and effectively provide services for the stakeholders. Next slide, please. Next slide, if we're on. I just lost my screen here. Hang on.
No problem. We're on the introduction slide.
Next slide, please. This was the problem statement that was outlined. Mike talked about it earlier. Pat talked about it. We're not going to cover it here, but I just included it for completeness so that we understood what we're talking about, and the fact that we've been working towards interoperability for a long time. We've made great strides. We still have a long way to go. It is a journey. We want to provide opportunities and capabilities for the stakeholders at the end of the day. Next slide, please. So some of you may ask, what is enterprise architecture? You may not be familiar with that role. It's a long-standing role inside the IT and enterprise organization. I put a couple of quotes here. The first one's from Jeannie Ross, who's actually at MIT. This is actually from a book she's published. She's one of the leading thought leaders in the enterprise architecture space. The other comment is from Gartner. But the bottom comment I like is architects comprise holistic solutions that address business challenges of the enterprise and support the governance needed to implement them. The intention is to be in the middle and understand what the business needs and simplify, consolidate, rationalize those needs against IT's capabilities, our network organization's capabilities, so that we can provide the right solutions at the right price at the right time. Next slide, please. So this is just a summary of our journey at Kansas City Power and Light. When I've been here as a manager of enterprise architecture a little over a year, I come from the telecom space originally. I've spent a lot of time in the telecom space, which is similar but different. But the challenges are the same. And I'm not going to go through the slide, but the goal is that we've got lots of things that were unstructured and non-standard, and we had a lot of unique processes. We're trying to move to structured, standard, and repeatable processes, and interoperability is a big piece of that. Next slide, please. So a definition of what is interoperability. I'm a big proponent of the Open Group Architecture Framework, which is called TOGAF. And the simple definition that they use is just the ability to share information and services. Gridwise Architecture Council has a little more complex definition, but it really gets down to that same basic tenet, sharing of information and services. I liked Elster's extension of this. Anytime, anywhere interconnectivity among hardware communications and applications. That's a great goal. The question is, how do we do it? I like the 3D view that they provided, and we'll talk a little more about that in a few minutes. Next slide, please. So why do we need interoperability? Pat showed the 2D interoperability and site slide, and I've got a slide that actually kind of depicts that in its very ugly, raw form in a minute or two. But we've got lots of complex systems. We've got back office systems. We've got utility metering systems, SCADA, DMS, outage management. We've got analytic systems. We've got external partners and services that we have to communicate with. We have to be able to interoperate and integrate with them. And in the past, we've done that in a very point-to-point, offhand fashion, or at least we have at Kansas City Power and Light. And I came out of the telecom space, that was much the initial approach there. So we've got complex environments. We've got lots of vendors. We've got different standards. We have different APIs. We've got a lot of custom applications. We may be in a model where we've got cloud applications. You're starting to get the picture. There's a lot of complexity. So with the right degree of interoperability, we can bring together applications and systems across the enterprise, irrespective of the vendors, to provide benefit for the business and our stakeholders. Next slide, please. Again, just continuing on this theme of why do we need interoperability. Simplify information sharing. We need to be effective in the way we use data and share it. One of the big goals is to minimize user intervention, minimize our time to implementation, and make things simpler. I kind of like this quote. People hear me say this in meetings. They look at me with cross eyes. If we always do what we've always done, we'll always get what we've always gotten. And that's complexity, long lead times to implementation, little reuse, and just a continued mess. So interoperability ultimately helps drive down the cost, provides a more simpler, reusable information sharing platform, gives us the ability to provide enhanced security at the right points, and provides a more reliable and monitoring and management solution around the use of our data and our interactions. The goal is to avoid these legacy 2D interoperability silos and patterns. Next slide, please. So this is kind of what that 2D view looks like at Kansas City Power and Light. And this is actually a very favorable view of it. In reality, it looks much worse than this. Lots of applications, lots of point-to-point integrations, lots of bolt-ons so the business can do what they need to do with the systems that we have at hand. In some cases, duplicate systems left over from mergers. You know, it's difficult to maintain these point-to-point integrations if we have to make a change to one application that has a huge ripple effect to others. It's difficult to change. It's very, very expensive to maintain. So this is what we don't want to do. So next slide, please. So the goal is how do we think about this from a holistic approach to bring interoperability to the forefront of putting applications together so we don't have that spaghetti mess that we saw in the previous slide. And this is from the Open Group framework, and I won't belabor the points, but I mean you have to have an architecture vision. From that you have to understand what the business architecture is. You really need to have a business architecture. You have to have a data architecture to support the business needs, applications that will be able to effectively use the data to meet the business's needs. You have technology. You need a technology architecture and roadmap that will support all three of the other architecture components, and you have to be able to implement and deliver those at the end of the day and continue to support them. Sounds like a lot of things to do, but it's the architect's role is to help plan this up front and see that we can get from the beginning to the end. Next slide, please. So some of the things that at Kansas City Power and Light that we're trying to do that we brought on board is we've found a standard infrastructure model so that not every application runs on its own set of infrastructure. We've got a common set of standards and all applications must run in it. We've gone to standard networking design. We've gone to standard integration or interoperation patterns and approaches. And those include standards for data sharing, data governance, and information sharing. At the same time, we've stood up processes to assess what the business needs and to have an understanding of where the business wants to go. You'd think that would be pretty simple, but IT has not always done that well. It means IT needs to be a partner at the table, not necessarily just an order taker. We have to assess our existing technologies, assess and accept new technologies, and be willing to limit the use of those that we're not going to grow those new technologies that are going to be our end state, and retire those old technologies that don't fit that end state. You know, architect uses standards and processes to work with engineers and build buildings and infrastructures. An enterprise or an IT architect uses that same type of process to build solutions to business problems. The former CIO here at Kansas City Power and Light used to you know, talk about engineers that actually manage big plant operations, and it's very much the same. Next slide, please. So how do we architect for interoperability? The goal is to create an environment where we don't have that spaghetti matrix of point-to-point integrations, that we decouple or we design in that 3D approach that Elster talked about, that we provide the capability for information reuse, that we really want to be able to get the data either in real time or as near real time as possible, that we can plug and play, that it's primarily a mapping of data between applications instead of coding of programs to get the data. And then one other thing that we've kind of learned internally, less may be more. And that may not make sense, but sometimes taking a look at your vendor selections and working with the right degree of vendors, the right set of vendors that have the right predefined interoperability standards, may simplify your approach to solutions. We happen to have a roadmap at Kansas City Power and Light where we're replacing a lot of these systems at one time, and that makes it easier to make those choices. But as you replace systems in the future or you modify systems in the future, you might want to keep that in mind, that the best of breed individual solutions, while they fit that individual need, may make it more difficult from a holistic approach across the enterprise. Next slide, please. So this is kind of what would be what our 3D framework starts to look like. Pat, it's not really in 3D, but it's the same concept. We're decoupling. We want to be able to move information across an information platform that decouples the applications and the use of the data across them. Next slide, please. I think we've covered most of these points. This is really a summary, but with the right interoperability architecture, businesses can bring together data and information from application systems across an enterprise, irrespective of vendors, to serve analytical needs and business needs. Next slide, please. That's it. And at this point in time, let's go back to Mike, and he'll bring Doug on for the next piece of the discussion. Thanks for your time.
And thank you, Richard. I think we'll be hearing from you during the Q&A as well as we move forward here. It is now my pleasure to introduce Doug Lambert, who is the Multi-Speak Program Manager. Doug has over 20 years of experience in the electric utility industry, fulfilling the technology needs of the utility for most of that time. He has played a role in the changes of software functionality as well as implementation of new software product lines as an answer to utilities' needs. He has implemented the development of a 24-hour operations control center, and as an IT manager of an electric cooperative, Doug oversaw the operations within GIS, CIS, information systems and data processing, network administration, and SCADA dispatch departments. Sharing of information and application integration has been a focus throughout his career. He has helped integrate the utilities OMS to the IVR, CIS, SCADA, and AMR and AMI systems using Multi-Speak. Today, he has the privilege to serve the industry as the Multi-Speak Program Manager. In this role, he works closely with utilities and vendors in ensuring the Multi-Speak interoperability standard is meeting the needs of the industry. Doug, the floor is yours.
Thank you, Mike. I appreciate the opportunity to be here and to basically reiterate a lot of the same points that have already been made, and to kind of explain the pieces of the puzzle and where Multi-Speak might sit in or fit into those pieces in fulfilling the needs of the 3D interoperability model. Next slide, please. So I know interoperability has already been defined twice today, so I'll just add to that definition a little bit, and then, like I mentioned, explain where Multi-Speak fits in. And I want to give a few examples of utilizing standards and interoperability of some cases where it's being used and the end results of that. I actually have some video links that are in here that we won't play today due to latency, but I would encourage you to go to those links after the fact offline and just watch those videos to see how does it really make a difference to the industry, how does it really make a difference to the customer, and to the utility as well. And I'll get into a little bit of the benefits of interoperability. And you know, when you mention about breaking down those silos, it's also between industries and sectors. I've recently been approached by the water and the gas industries wanting to apply those same types of standards that we've done here to those industries, which then helps munis and those that may be serving customers in other ways other than just electricity. So that's it's about not only being standard within our own industry and with our own enterprise, but also across sectors. And then we'll have a few concluding thoughts. I'm sorry, next slide, please. I'm over here clicking. So the definition of interoperability, here's one more definition. This actually came from the healthcare industry. And it's the ability of different information technology systems and software applications to communicate, exchange data, and use that information that has been exchanged. And I like this part here, which is regardless of the application or application vendor, you should be able to pick which vendor and unplug a vendor and plug another vendor in and still have that interoperability happen. So it's systems working together across boundaries even. So next slide, please. And Multi-Speak is, like I mentioned before, one piece of the puzzle of this. There's so many standards out there, and those standards have to work together. And it's recognized as one of the leading standards for enterprise application interoperability. We have 725 utilities, a combination of electric co-ops, investor-owned utilities, munis, and public power districts using it today in at least 19 different countries. They don't always tell us when it's being implemented somewhere, so those are our best estimates based on information provided. Next slide, please. And I'll show how, like I mentioned already, how we're going to, what role we're playing in enabling smart grid technologies to communicate with one another. Next slide, please. So if we look at NIST framework, which NIST, the National Institute of Standards and Technology, I know we use a lot of acronyms in this business, so sometimes it's a good idea to spell them out. But they've developed a smart grid conceptual reference model as part of the smart grid standards framework roadmap, and there are 42 different standards necessary according to NIST in order to support the vision of smart grid. And the section in blue for distribution operations and a little bit on the demand management on the transmission operations is the area that multi-speak meets. And then it's also about, on those fringe areas, being able to share data between other standards as well, and harmonize between those standards is a big piece of that. So it's not only about breaking down the silos within the enterprise, but breaking down the silos between standards as well, to make sure that all the needs are being met for the utilities as well as for the customers and the service providers and the market. Next slide, please. And I want to talk to you about a few of these use cases where it's been put into place. For instance, prepay. At the utility, before I left the utility, we implemented prepay. And in order to implement prepay, we put in a new AMI system that had remote disconnects in the meters. And then we used multi-speak to talk to the AMI system from the CIS system so that we could automate the process of connecting and disconnecting those meters. And then we also had to automate that to the payment gateway and to the outage management system so that it was aware when that meter's been disconnected so that you didn't roll trucks. And that's real savings by not rolling trucks and when they're not needed. And it's also a safety aspect in that you don't want service linemen showing up on scene where they've been disconnected for non-pay. Sometimes that could be a touchy situation. Next slide, please. And by automating these systems, we've reduced the human interaction. Prior to putting this system in place, the dispatchers in the 24-hour dispatch office would take payments using credit cards. And they would enter those credit cards into the payment gateway system on the internet. And a lot of times they were writing those credit card numbers down on sticky notes. So we took the human interaction out to reduce the risk with PCI compliance. And by adding this automation in there and this interoperability between these systems, then it allowed us to take the human out and at the same time improve the customer experience. Allow that customer to interact with the systems at their convenience, and it allowed us to offer that at a 24/7 on a 24/7 capabilities. And there's a video testimony from another co-op. It's actually Wake EMC out of North Carolina. There's that link there where they talk about multi-speak making this possible through an all-in-one solution that prior to having integration. So next slide, please. And this is Don Bowman, and he's the head engineer at Wake. I'm sorry, that should say EMC instead of EMS. And this is what he said about integration. The integration of our systems has made it possible to offer the prepay solution to our customer members. So they weren't able to offer this prior to integrating the systems together. So next slide, please. And if you watch the video, this Bessie, she gets really animated and really passionate about how it has changed her life by allowing her as a customer to control how she spends her money and to see how her energy is being used and to make changes in her life so that she knows exactly when that money is going to be spent instead of after it's been spent, worried about her lights being turned off. Next slide, please. And from an outage management standpoint, years ago we had tied in the AMR systems, the one-ways, power line carriers where we could ping the meters from an outage management system. And just by putting in that one interoperability piece, we had estimated saving over $50,000 in man hours for that 1 year. And all that is where when a customer would call us and say we're out of power, prior to having the technology to ask the meter, are you really out of power, we would just roll a truck with 2 men in the truck. And a lot of times that would be after hours or on weekends, so now you're paying overtime to those guys as well. And by allowing the outage system to ping the meter, then they could, if it was on, then they could talk to the customer and explain to them how to flip their breakers. So that's just one example. And then if you apply that throughout and to all the different interfaces, then you can see how that can add up. And then, of course, when we moved into the AMI world, it was about the two-way and how that evolved, which was already mentioned earlier about how AMI pushed a lot of this interoperability in that it could do so much more than the AMR. And if you're going to invest as a utility in an AMI system, you want to leverage all the data you can out of that meter. If all you're doing is getting a reading from it, then you're missing the abilities of the system. And you're also doing a disservice to your customer in the investment by not utilizing all the data. And how do you utilize that data? You've got to be able to pull it out and do something with it, and do that through interoperability and through standards. Next slide, please. So basically, I think I've gone over this already, but when we implemented that, the alarms, we were able to see not only for outages, but power quality. So we were able to see the blinks and things that, and see the true customer experience so that you could improve upon that. So it's about taking that data, analyzing that data, and doing even more with it and improving upon our indices for outages. Next slide, please. And that's just an example showing an outage system integrated to an AMI where the meters were self-reporting. And in this case, there was 1,500 meters reported in before a single phone call came in. And with a good connectivity model, phone calls became unnecessary in order to predict the correct devices that's being opened. And in this case, also SCADA was verifying it to the outage system as well. And it's kind of hard to see on there, but there's also trucks driving around so they could see the live locations of those trucks. So you've got several integrations right here in one screenshot: AMI, AVL, and OMS, and SCADA. Next slide, please. So what are some of the benefits of interoperability? And some of these, just from looking at the use cases, are pretty obvious, but it improves customer member service is obviously our #1 priority there. And streamlining of automation of those processes, it relieves some of the stress and some of the training that's needed on your staff. For instance, if a dispatcher is used to operating in the outage software, he shouldn't have to bring up a head-end software for an AMI to query that system for information needed by the outage system. That, #1, slows down the process, and so your customer service suffers, and it also makes you look less professional, and it also requires you to train these guys in more software, and it takes them out of their comfort levels as well. And also the data integrity with the data being shared in a standard way. If you've written a lot of custom integrations, sometimes who owns that data, and is that schema, does it change through time with updates, then who's going to support that? You're going to have a technical staff that can keep all those pieces running all the time. And so to relieve that burden off that technical staff, and also then if you've got an IT staff that's pushing data around and they don't really understand the value to the engineer or to the operations group, and they're not giving you the full picture, whose responsibility is that? So it's about taking that burden away and putting it onto the standards so that they can guarantee that all the data is coming through in the right manner. And of course, it results in real cost savings for the utility and the vendors, and that they're not having to write custom integrations for every new technology that's brought in. And I gave the example a while ago about the AVL to the OMS of being enhanced safety. When I was at the utility, when we implemented the AVL to the OMS, we tied that to our lockout-tagout procedures. We wouldn't even allow them to energize the line without first checking through AVL as well as making that part of the lockout-tagout procedure. And it, in a few instances, kept some close calls from happening. So next slide, please. And I mentioned before that it's also now, there's other industries that are looking at the examples here and are doing some similar works. The Water Research Foundation now has approached us, and we do have an MOU with them where they're doing some work to extend multi-speak into water. And the Gas Research Institute, working through the Smart Grid Interoperability Panel, has approached us as well, and they're in the investigative stage right now to see how they can also apply standards to their industry, and then how we can work with those standards so that they all work together, whether they be the same standard, an extension of the same standard, or other standards. So it's about keeping those lines of communications open as well. Next slide, please. And there's just another video link of another interview just talking about, and this was when I was at the utility. But when we first turned on interoperability, one of the things that we noticed was the AMI system was telling the outage system that this one location had high voltage. And I didn't believe it because you don't trust those systems right away when the data is flowing. You trust yourself. That's kind of the nature. And so we went into the AMI system and said, does she still have high voltage? And the AMI system had the history in there of 18 days this lady had 270 volts outputting at her house. She never called us. The only way we knew it was we rolled a service truck out there and found a bad transformer. And that's the kind of thing that where this makes a difference in their lives and the lives of our customers without them having to call us and make the difference themselves. It's about helping the little old lady at the end of the line. Next slide, please. And I believe I'm finished, so if Mike, we can turn it back over to you.
Very good. And thanks, Doug, and thanks to all of our speakers. We do have just a few minutes for some Q&A, and we do have a few questions here. I'm going to jump into this pretty quickly because we are up against the wrap-up here. My first question is for, first one we've got here is for Richard. And Richard, this refers to your slide where you showed your legacy systems. The question is, our legacy interoperability map looks much like your legacy slide. How does an organization start to migrate away from that model without throwing away all the current interfaces?
So architecture has to be incremental, and I'm speaking sheerly from the integration architecture standpoint. As you start to think about making changes to integrations and interoperability from a legacy standpoint, I mean, Doug talked about, reuse. That's exactly where we want to head. Simplify it. Don't build something bad that you're going to have to throw away down the road. And if you've got an interoperability plan or an interoperability program, use it to do the new integration, because the next application that comes along that needs that same data may be able to reuse it. It starts so you can incrementally start to transform that ugly map to the future state that's either the 3D type view that Ulster talked about or the slide I had in the after. I mean, it's a journey. It's a one step at a time. You don't throw everything out at one time because you can't afford to. Does that make sense?
Yeah. Thanks, Richard. And you know, we are up against it, but I'm going to try and squeeze in one more question here. This one is for Doug, and this is around the issue of scalability. In most cases in our industry, the smaller utilities follow the larger utilities in terms of looking at how technology is implemented. Are there issues around small utilities being able to go down the interoperability path as easily as large utilities, i.e., does it scale in such a way that it's still affordable for the smaller utilities? And Doug, I think with your experience working with NRECA, you might be in a good position to answer that one.
Yes, absolutely. I actually came from a smaller utility. We had 26,000 meters. And we had a very tight budget. We had a staff of 4 for the IT staff to manage everything. And we had implemented multi-speak and as an interoperability standard throughout our enterprise and had it working in about 80% of our systems. And it was a very, very small portion of the overall budget. And it allowed us to free up our time so that we were able to focus on other things and not worry about every time there was an upgrade. Did we need to also do something to upgrade that system? And I would also argue that the smaller utilities don't always follow the larger utilities because it does take the larger utilities longer to implement technology plans. For instance, whenever we implemented our AMI system, we had it 100% deployed in less than 1 year because we were smaller, so we can move faster on technologies. So there's some advantages there too, but you also can't afford to make mistakes. You have to make sure you're making those right decisions up front the first time. So that's why we always rely on the community of other utilities, of talking to the cooperative communities, of those that have paved the path before us as well. And that's why it's important that we rely on standards to get the job done. But yeah, it absolutely applies to the smaller utilities as well as the larger utilities. Did that answer the question? Was there more to it?
Yeah, I think we're good. And actually, I think we're about the point where we need to wrap up. So again, thanks so much for everyone for attending today and for our speakers. And I'm going to hand the floor back to PJ, who's our moderator.
Thanks, Mike, and thank you, speakers. Excellent presentation. We hope our audience, we hope you've enjoyed today's presentation. As you log off, please take a moment to complete our survey so that we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.